In this lesson, we're going to look at the application part of this section on exponential functions. So basically, it's going to look like this, and there are really just two types that you're going to look at. So for example, here are the problems we're going to look at. So it'll say, find the accumulated value of an investment of $30,000 for 4 years at an interest rate of 7.5% if money is compounded semi-annually, compounded quarterly, compounded continuously, and then here's another example. And then number 3 says, suppose you have $13,000 to invest, which of the two rates would yield the larger amount in 5 years? And then 8% compounded monthly or 7.88, and that should be percent right here, 7.88% compounded continuously. Okay, so in order to do those two problems, though, so there are two formulas that we're going to look at. Two formulas used for compound interest. So this would be compound interest. Okay, compounded interest. All right, so that's basically what we're looking at in this section on exponential functions. Now, you don't have to memorize these formulas. We will give you these formulas, but here's the first one. So the first form you're going to use is this. A equals P times 1 plus R divided by N, and that is being raised to the NT power. Okay? All right, so let me just kind of talk about what each of these represent. So the P here, P represents the principal. So that's the original amount, sometimes called the original amount. Okay, so that's the principal. So that will be the amount that you invested. R basically, it kind of says what it is. It's the rate, the interest rate. All right, and when you put in the formula, make sure it's written as a decimal. Written as a decimal. Okay. T is the time, and it's in years. Time, and it must be in years. Okay. N, all right, now N is the number of times per year, interest is being compounded. Okay, number of times per year, interest is compounded, and A would be obviously the accumulated value. So the amount, A is the amount you end up with, the accumulated value. Okay, and then the other formula will be this. So the other formula will be this. It will be A equals, so there's the other one, A equals P times E, so remember the number E, and the exponent is RT. Okay, so that one's easy to remember from most students because it says PERT, and the shampoo PERT. All right, but so P again is the principal, A is accumulated value, T is the time, and R is the rate. So E, remember, is your constant, so that's an irrational number. So the thing missing from here, if you look at this, what you don't see here is N, right? So N, remember, is the number of times your money is being compounded per year. Well, E here, to use this formula, if money is being compounded continuously. So if you see the word continuously, then that's when you're going to use. So if you think of the word continuously, that means a kind of like an infinite number of times. In here, the number of times per year, that's a finite number of times. So if you see the word quarterly, all right, so how many quarters are there in a year? There are 4. So that would mean that N would be equal to 4. If it says monthly, what do you think N would be? So N would be, how many months in a year? 12. The other one would be, let's say, semi-annually. What would that be? N would be, how many semi-annuals are there in a year? Okay, so there would be 2. All right, so those are the ones that you would need. And you could also use daily. Daily would be, just assume there's 365 days in a year. So if it says daily, N would be 365. Okay. All right. So see, that's a finite number. So finite you can count. The n is 4. You can count on your fingers. Uh, Monthly 12. So you can do the same thing. That's a finite number. Semi-annually 2. Daily 365. That's a finite number. Continuously, that's an infinite idea. So use that formula here. So most banks, though, will probably use one of these up here. So probably monthly or something like that. But just talk to your bank and see which one, if you have a savings account, which one they use. All right. But savings account, the interest is pretty low, so you don't get much in a savings account. All right, so let's look at these problems now. All right, so we can see how to use those. So have this in front of you. If you need to, take a picture of this. Okay? Take a picture of this now. Pause this. Take a picture because you're going to need this for this. All right? Okay, so here we go. All right, find the accumulated value of an investment of $30,000 for 4 years at an interest rate of 7.5% if the money is A, compounded semi-annually. All right, so the formula you're going to use, if it's semi-annually quarterly, that's going to be this one, right? Continuously, if it says continuously, then that's the PERC one. All right? Okay, so here's what you're going to do. So the accumulated value, what you want to find is A. So A equals P is the principal. What's the principal here? What are you investing? You're investing $30,000. That'll be 30,000 times 1 plus R. What's the rate? 7.5%. But remember, you got to write it as a decimal. So what's 7.5% is a decimal? You move the decimal point 2 places to the left. Remember how to deal with percents? Changing a percent to a decimal? Because remember, percent means per 100. So you divide by 100. So you move the decimal point 2 places to the left. So that's 0.075 divided by n. And remember, it's the number of times being compounded per year. Semi-annual is how many times a year? 2. All right, all raised. And what I would do is I put this in parentheses. All right, put that in parentheses up here. Because sometimes the time is a decimal, sometimes it's a fraction. But in our case, it will either be a terminating decimal or a whole number. All right. Okay, so NT, so N is 2 times T, which is how many years? 4. So T is 4. Okay, all right, now watch carefully how we put this in your calculator. Use your calculator. All right, so we're going to write it, you're going to enter it into your calculator just like you see it, okay? Just like you see it. Don't forget to put this in parentheses, though. If you don't, and at the end you say raised to the 2 times 4, that's your calculator is going to give you the incorrect answer. So put that in parentheses. Put the exponent in parentheses. Okay? All right, so you're going to say 3,000 just as you see it. 3,000. Okay? Parentheses. So that automatically means times. Parentheses 1 plus 0.075 divided by 2. Close the parentheses. So that part wasn't difficult. Now you got to raise it to an exponent. So you go raise right here, parentheses, 2 times 4. Close the parentheses. Make sure you close it. All right. Equal. And remember, we're dealing with money, so you're going to round to nearest hundredth. Dealing with money, so nearest hundredth. So the hundredths place. So $4,027.41. Okay, so that's the accumulated value. All right. Now here's a question though, and so listen to this carefully. What if they ask you? So let's say this is in a savings account, right? So let's say they ask you. All right. So that's your accumulated value. So you're 30,000. Oops. I'm sorry. So notice I just realized something is wrong because I said 30,000 and also this is my accumulated value, which is less. What happened here? What did I put in? 3,000. What should it be? 30,000. So let me go ahead and add another 0. So I'm going to insert a 0. All right. So you should get $40,274, right? So let's do that again. So $40,274.12. Okay? All right, so that should be the correct one. So So notice I knew something was wrong because that was less than this. All right, but so that's your cumulative value. So what that meant is that you went from 30,000 to a little over 40,000, correct? What is that increase, do you think? You use your own experiences. This is what you put in. This is what you ended up with. So you had an increase. What is that increase made of? That's your interest. That's the interest you earned. So if you want to know the interest earned, if you want to know that, which I didn't ask you here, but if you want to know, you would just take your accumulated value and subtract your principal from it. So the accumulated value is this, and then subtract the principal. And then if you use your calculator, but you could do this in your head, that's just $10,274.12. So that's how much interest you earn. Okay? It's not that bad, only because that's a pretty good interest rate. Most interest rate for a savings account is probably 1 point something or less. All right. Okay. Letter B. All right, suppose that same $30,000 though is being compounded quarterly. So basically what I want you to see is what's happening with this amount here. So this was so your money was being compounded twice a year, and even the interest as well. And now it's being compounded quarterly. So quarterly means how many times a year? 4. So it's being compounded more times, right? So let's see what happens to this amount. All right, so you're still going to use the same formula. A equals 30,000 times 1 plus 0.075 divided by, so everything is almost the same except for n. What's n in this case? So quarterly means n is 4, right? So you can say 4, all raised to the, and then 4 times 4, right? So n is 4, time is still 4. Everything else is the same except for n. Okay, use your calculator. All right, so you're going to do the same thing. You're going to say 30,000. Make sure you say 30 and then 3 zeros. Times 1 plus 0.075 divided by 4. Close the parentheses. Now I'm going to raise it. Parentheses. 4 times 4. Close the parentheses. Equals, and then that's $40,383.43. So it increased, right? And it increased because it's being compounded more times per year. So the more is being compounded, the more money you end up with because your the interest is even earning interest, right? Okay. All right. Now let's look at continuously. So if it's being compounded a finite number of times a year, then you're going to use this formula here, right? If you are compounding continuously, then you're going to use this formula. And so you're going to get A equals the principal, which is 30,000, times E to the rate, which is, put that in parentheses, 0.075 times T. So remember RT, so times T, and T is still 4 years. And then use your calculator. All right, so when I use a calculator, this becomes 30,000 times E, you can say times, and then remember to get to the E, you press second ln, remember that? Right here. See that? And then in parentheses, you can say 0.075 times 4. Make sure you close the parentheses, and then press equal. And so that's $40,495.76. And notice that the more times it's being compounded per year, the larger this amount is. So in not always the case, but almost always, again, not always though, continuously will give you the most money in certain situations. Now, if you compare the same numbers here, yes, continuously will work, but will give you the most. But if you're comparing like two different rates, that's not always true. So you gotta actually look at each one. But when you are looking at the same values and just put into these formulas, the more times being compounded per year, the larger the accumulated value. Okay? All right, number 2. So this time it's $12,000 for 3 years at 4.5%. So again, you're going to say A equals. All right, now this time remember monthly ends in is 12, right? So I get A equals 12,000 times 1 plus the rate, which is 0.045. You have to write that as a decimal, divided by n, which is 12, raised to the, and remember it's this, here's your formula, nt. So n is 12, and t is 3. Put that in parentheses. And then now let's use a calculator. So if you use your calculator, you're going to get 12,000. Oops. 12,000 times parentheses 1 plus 0.045 divided by 12. Close the parentheses. Now you're going to raise it right here to the parentheses 12 times 3. Close the parentheses. Press equal. And you get $13,730.97. Okay? So a little over almost $2,000 in interest. All right, the next one. Okay, part B. All right, part B, let's suppose you had, now this time it says quarterly, so n is 4. So everything stays the same except for n. So you would expect this to increase, right? Because you're using the same values here. You're just changing n. So oops, sorry, this is 12, so you expect that to decrease because this is compounded 12 times a year. This is what? 4 times. So that would be decreasing, correct? All right. So A equals 12,000 times 1 plus 0.045 divided by 4. So this was 12 times a year, so interest is being compounded 12 times a year, whereas this one's only 4. So that number should be smaller than this one. Raise the 4 times 3, and then let's approximate. So 12,000 times parentheses 1 plus 0.045 divided by 4. Close the parentheses. Raised to the 4 times 3. Close the parentheses. Press equal. And you get $13,724.09. So you see it's less. It's not less by much, but it's still less. Okay? All right, and then compounded continuously. So remember for that, you can use the PERT formula. It says continuously, that's the PERT formula. So we get A equals 12,000. Now, when we this answer should be more than these two, correct? Because continuously it implies an infinite number of times. You're still using the same values up here, so that should obviously be more than these two. All right, so 12,000 times E in parentheses, the rate, which is 0.045. Always change that to a decimal. Times the time, which is 3. And let's see what we get. So we're going to get 12,000. 12,000 times E. Okay, and you're going to say 0.045 times 3, close the parentheses, and then press equal, and you get $13,734.44. So notice that this amount is larger than these. Not by much, but still, it's still larger. Because compounding continuously, given the principal, the years, and the interest rate being the same, compounding continuously gives you the more money. Okay, number 3. Suppose you have $13,000 to invest. Which of the two rates would yield the larger amount in 5 years? 8% compounded monthly or 7.88% compounded continuously? All right, so let's see. So here's how you would do that. Okay, so for that one, you would say, let me go ahead and get another paper. All right, so for that one, okay, so let's look at the 8%. Let's do this. The 8% interest rate. So let's find the accumulated value. So accumulated value, now which one do I use? Do I use the PERT formula or do I use the other formula? It's the other one, right? Because n is 12. N is 12. So it'll be 13,000, okay, times 1 plus the rate, which is 0.08, divided by n, which is 12, raised to the 12n times t, and t is 5. Okay, so let's see what that is. So you can say $13,000 times 1 plus 0.08 divided by 12 raised to the, okay, don't forget raised to the parentheses, 12 times 5, close the parentheses, press equal, and you get approximately, right here, I'm going to do that right here, you get approximately 19, oops, something's wrong. Let me go back and, because that's a lot. Well, it's 8% that amount, so that's fine, and 12 times, so that's $19,367.99. Okay? All right, because that's 5 years, 8%. So 8% is it's a large interest rate, a high interest rate in 5 years. It's quite a few years. All right, so let's look at this one then. So let's look at the 7.88%. All right, so now this time I got to use the PERT formula because it says continuously. Okay, continuously. So A equals the principal, which is 13,000, times e to the rate, RT, so 0.0788, times the time, which is 5. Okay, and then let's see what that is. So 13,000 times E, okay, 13,000 times E, so you're going to say second, ln, that's how you get your E, and then 0.0788 times 5, close the parentheses, press equal, and that's about $19,277.71. Okay? All right, now here's the question. Why is it that in this one, in these, the continuous part was always the larger, and in this is smaller than this, isn't it? Why is that? Well, because the interest rate is different. And see this says 8% compounded monthly, and this says what? 7.88% compounded continuously. That's why if you're looking at two different interest rates, it doesn't always mean that don't always assume that the continuously is always going to be the more. Will always give you more, okay? So it depends on the interest rate. So probably if this was a little bit closer to 8, like let's say 7.9 something, then probably this would be a lot more than this. Okay? All right, so, and then it says which of the two rates would yield the larger amount? So you would say the 8% rate would yield, so make sure you answer the question, the larger amount. Okay? All right, so that's going to take care of, so your problems on that worksheet is going to look just like this, and on my math lab, the same thing. Okay? So go ahead and use this to help you with my math lab. So that takes care of the lesson on compound interest. All right.